Okay, for this question, we have to design a deterministic pushdown automaton recognizes precisely this language. Now we can't just do the same trick where we sort of just build a context-free grammar for it and then convert it using the algorithm, because that would give us a non-deterministic pushdown automaton. So we're going to have to do it the hard way and design this thing from scratch. So the first thing you should think about is, what sort of language is this? So what do we have? We have 0 to the n, 1 to the m, and the hash symbol, where n is greater than or equal to 1, and m is strictly greater than n plus 2. I'm going to rewrite that as m is greater than or equal to n plus 3, because I think that's easier for me to understand. So what sort of things are in this language? So it's got to have at least one 0, and then might have a bunch more zeros, and then it's got to have a bunch of 1s, and the number of 1s that are here has got to be at least the same as the number of zeros, plus 3 more. So I'm thinking the way I should solve this problem is, for every 0 that I see, I'm going to push it up on the stack, and then when I see 1s, I ignore the first 3 1s, and then I match and pop. And then if the stack's empty at the end, I'm going to keep accepting 1s until I see a hash, and then I empty the bottom stack symbol. So that's the algorithm I'm going to use. So here's my starting state. So I know I'll see at least one 0, there has to be. So if I see that 0 and the bottom stack symbol, shove it up on the stack. And if I see 0 on the input and more 0 on the stacks, as long as I keep seeing zeros, I'm going to keep shoving them up on the stack. So if my input string is 5 zeros at the start, then we're going to have 5 zeros up on the stack. And then what do I do when I see 1s? Well, I want to match the number of 1s against the number of zeros, but there has to be at least 3 more 1s. So I'm going to ignore the first 3 1s. So if I see a 1 on an input, and obviously I'll see a 0 on the stack, I'm going to not touch the stack. I'll leave it well alone. I'm going to do that 3 times. So I see the second one, leave it well alone. And then I see the third one, leave it alone. So now I'm going to set S3. So if I've got 5 zeros, I have to have at least 8 1s. So let's say I've got 9 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've read this part of the string, and then I've consumed 3 1s. And now there has to be at least 5 1s. So at this stage, for every 1 that I see, if there's a 0 on the stack, I'll pop it off and push nothing back. So I see a 1, pop, see a 1, pop, and we'll repeat this process until the stack is all out of zeros. And again, we still have the bottom stack symbol. And now I'm still allowed to have as many more 1s as I want, right? So if I see a 1 on the input and the bottom stack symbol, I'm going to put the bottom stack symbol back so I can keep accepting as many 1s afterwards, which is totally fine, because all I need to guarantee is I have at least n plus 3 many 1s, but you could have more than that. And then when I finally get to the hash symbol, I see the bottom stack symbol, I pop it off, and then I go to the final state. And then all the conditions for my PDA should be true, in that if you get to the final state and the input is empty and the stack's empty, you accept. So you have to ensure all 3 of these properties hold, or might accept the wrong language. So does this machine work? Well, if it's got anything other than a 0 at the start, clearly it's going to fail and get stuck. If it's got too few 1s, so maybe 4 zeros and 5 1s, let's see what will happen. So to push the 4 zeros up on the stack, so that's all my zeros read. If I see a 1 on the input and a 0 on the stack, I consume both, and then I do that 3 times. 1, 2, 3. And then what am I going to do? Oh, sorry, no, I'm actually wrong about that. You ignore the first 3 1s, that's right. So you ignore the first 3 1s, and then we get to S3, and then I match and pop the 1s. Match and pop, and then I get stuck. So there'd be the hash at the end, but I still see zeros on the stack, so then the machine will again fault. So it looks like this machine works. There's many different ways you could do this. This is just one possible way. Another way you could do it is you could just push 3 zeros on the stack to begin with to compensate for the extra 1s. You could have extra states at the end to compensate for the extra 1s. There's lots of different solutions, but this was my solution. Okay, so what's the next question? We have to give a trace to show that this machine what accepts the string. So it has to accept 0, 0, and then 5 ones. So 0, 0, 1, 1, 1, 1, 1, and then a hash. And we need to show that it rejects the string 0, 0, 1, 1, 1, 1. Okay? So why are these strings in the language or not? I mean, that should be the first thing we check. So what's the property? There has to be at least one 0, and there has to be at least 3 many more ones than there are zeros. So this string is 0 to the 2, 1 to the 5, and is 5 greater than or equal to 2 plus 3? I mean, yes, because 5 is equal to 2 plus 3. What about this string here? 0 to the 2, 1 to the 4, is 4 greater than or equal to 2 plus 3? No, it isn't. So we should first convince ourselves that these strings really are and aren't in the language. And now we're going to do the trace. So I'll do the trace in a different color. So what's the trace look like? So I start in the starting state. I've got that as my input, 0, 0, 1, 1, 1, 1, 1, and then a hash. And what's my stack look like? Well, it's just got Z on it for the moment. Okay, so what's the machine do? If it sees a 0 on the input and a Z on the stack, we push 0Z onto the stack. So one of my zeros goes away. I've got 0, 1, 1, 1, 1, 1, hash 0Z. And then while I keep seeing zeros, I just keep pushing them onto the stack. One of my ones fell out. There we go. 0, 0, Z. And then if I see a 1 on the input and a 0 on the stack, I just do nothing. So I leave the stack alone, and we have 4 ones left and a hash. And we transition to S1. So I need to edit that. That should be an S1. I'm in S1. I see a 1 on the input, 0 in the stack. I do not modify the stack and go to S2. So we go to S2. We consume a 1 from the input, and my zeros stay the same. And do this one more time going to S3. So go to S3, consume another 1, and then I got 2 zeros left. Okay, so now what does my machine do? So I match and pop the ones with zeros. So if I see a 1 on the input and a 0 on the stack, I consume them both. And I go straight back to S3. And then I do this again. I'm in S3. I see a hash on the input. I see a Z on the stack. I pop and I go to S4. So now my input is empty and my stack is empty, so we accept. Okay, so that's the accepting trace. Now let's try the rejecting trace. So it's the same thing again, starting as 0, but we have 1 fewer ones. So 0, 0, 1, 1, 1, 1, and the hash symbol, and the stack starts with a Z on it. So what's the machine do? If I see a 0 on the input and a Z on the stack, I put the 0 on the stack. So we have 1 fewer zeros, 1, 1, 1, 1, hash symbol, 0, Z. If I see a 0 on the input and a 0 in the stack, I push another 0 up. So I've got 4 ones, a hash, now 0, 0, Z. If I see a 1 on the input and a 0 on the stack, I leave the stack alone and go to S1. So we'll stay S1, and now I've only got 3 ones left. So one of my ones got used up. I do that again, so we go to S2, consuming a 1 and leaving the stack alone. And then we do that again, going to S3, leaving the stack alone. And already we can see there's going to be more zeros on the stack than ones on the input, which probably indicates this is going to fail, which is good, we want it to fail. So I'm in S3, I see a 1 on the input, 0 on the stack, push nothing back. So S3, hash, 0Z. Now, from S3, I need a transition where I've got a hash on the stack, but a hash on the input, but a 0 on the stack, and it doesn't look like I've got that, right? There's no transition of this form. So I get stuck, and therefore I reject. And there we go. So that's the accepting and rejecting traces of these strings.